Welcome to another video of polymers and composites. Hi there, this is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. Today we are going to see about the topic bakelite. So before knowing the bakelite, we need to get any materials which is expensive and also it's easily damaged, it's unsafe for electricity. So there was a need to get a strong, cheap and a non-conductive material that can be used for the electricity purposes. So existing materials were unsafe and also costly and not suitable for growing electrical technology. So there was a need for a strong, affordable, heat resistant and non-conductive material. The idea was the solution that the scientists explored different chemical combination and Leo Baekeland experimented with phenol and formaldehyde to find a strong heat resistant plastic. So he made using the phenol and formaldehyde, that is using the heat and pressure. So you can see the reaction in the screen. So the material was tested for the heat, resistant, strength, and electrical insulations. So the result shows bakelite, which was a durable, non-conductive, and fire resistance. So how do you prepare this bakelite? So it's made by condensation of phenol and formaldehyde. So phenol and formaldehyde, it was molded under the heat and the pressure into the final products. So you can see the reaction in the screen. This is ortho and the para hydroxymethyl phenol. It forms as an intermediate. Then after that you get a novolec. It is a linear polymer. So the novolec, it again it reacts with the formaldehyde to give the bakelite. It's a cross-linked polymer. So bakelite is a cross-linked polymer. So the applications, it was widely used in the electrical items like switches, plugs, sockets, and radio casings, and also used in the kitchenware, jewelry, buttons, and mechanical parts. So this bakelite, they made a switch with porcelain base. Okay, so the current were in 6 amperes and the voltage is 250 volts, and it has many advantages. So it's just we have to recall this. So what is bakelite? How it is prepared? It is heat and pressure resistance, and the applications in the various fields like electrical insulation, household items, then automotive parts. It's also used in the buttons, electrical installations, and electrical insulators. So the properties is hardness, heat resistance, and also chemical resistance. So these are the some of the important that is the properties of the bakelite and also the applications. So here you have an assessment question that is bakelite is formed by the condensation polymerization of which pair of monomers? So it is not ethene and propane. And next choice is the phenol and formaldehyde. Yes, of course, it is phenol and formaldehyde because it's not going to be styrene and butadiene and also adipic acid and hexamethylene diamine. So the next one is which of the following is the most appropriate classification of bakelite? So you can see that linear thermoplastic polymer, which is not the correct answer. Branched thermoplastic polymer, no. So what we see in the previous slide, that is, it is cross-linked thermosetting polymer. So after forming the Novolac, we saw the final product. It is a cross-linked product of the bakelite. And D, again, it's not. It's elastomeric polymer. So already we have come to a conclusion of the choice C. So bakelite, it is really a wonder, which is a cross-linked polymer of a thermosetting polymer. After the finding the bakelite, there are many electrical installations, many different types of electrical installations were made possible. And also it is highly heat resistant, it's highly thermosetting polymer.